Today we discuss about electrostatics part 1. Electrostatics, that means they relate with the charge concept, how to charge produce, and what about the production of charge concept. Very simple concept. Each and every body always in neutral state. For example, suppose this is a body, an object. It has their positive and negative charges. Because we know that each and every body has their same number of positive and negative charges. It means it is always in a state of neutral. Again, but how to produce a charge? Same as I have energy concept. Energy cannot be created, neither be destroyed. Same as charge cannot be created, neither be destroyed, because they follow the law of conservation of energy, same as the law of conservation of charge. That means then how to produce this charge? When two bodies are rubbed together. First we say that some example, very simple example. This is a plastic object that side. If this part is rubbed with your hair and after that comes near your ears, they will attract towards. Why? Simple. That's charged up. This is charge up. First we produce the charge, and how many types of charges. This is a body A and another body B. It means they have 3 positive, 3 negative, another body. Another one has their 6 of them positive and negative charges. When these two bodies are rubbed together, therefore, the loosely bounded electron of one body, loosely bounded, that's important. It means, another words, very important, its work function is low. Its work function is low. Then, these two bodies are rubbed together. Then outermost shell electrons or the loosely bounded electrons are jumped out from one body to another body. It means there is a space vacant and one charge, negative charge is moved towards, one electron is moved towards. It means there is the axis of electron is produced on body B. B is negatively charged. And body A, it has less number of electrons and deficiency of electrons, but the positive charges increases. Then this body is positively charged. Then again we rub together. Then again it's moved towards negatively charged, and this one is positively charged. There is positive or negative charge are produced separately. They could not be developed by this one. They rub together, then the charged electrons, outermost or loosely electrons, are shifted to one body. Same example, A is positively charged. In second case, B is double negative, then A is double positive. Simple. In chemistry, we know that. It's very simple. Conclusion is, suppose NaCl. Its electronic configuration is Na plus Cl minus. That means one positive, one negative. It means there is an excess of electron on chlorine and there is a deficiency on sodium. And another example we have taken at AgNO3, same as Ag plus NO3 is a negative. Another example for this one, S2SO4, then twice H positive plus SO4 double minus. That there is one body is positively charged, another is negatively charged. Therefore, the charge can be produced or transferred from one body to another. And this is a conclusion of production of charge. Then how to charge the body? There are, I hope that 2 silent methods are there. First, to touch one body by another body, that means the charge is transferred, and this method is known as conduction. And another method is induction. That means we does not touch these bodies, if nearby or this one and this one is produce a charge. How it is possible? By induction. That's my another topic, is charging a body by induction. By induction. How to charge the body by the phenomena of induction? That's very simple concept. This is a neutral body. Again, what do you mean by the neutral? It means it has their same number of positive and negative charges, and we comes towards nearby this a positively charged body. Correct? Isn't this condition? First of all, second case, isn't we are writing a different diagrams explained to you by different diagrams. It has number of positive and negative, similar concept said. Another, we have their positively charged body towards it, do not touch by induction. Isn't this condition? Towards it a negative charge comes out and another side and positive charge. Then again, there is simple concept. There is a negative charge, there is a positive charge, and we have their positively charged body. When it is connected with the earth, we connect with the earth with this side. In this condition, these charges, these positive charges shifted towards earth. Shifted towards earth. That's correct? No, my dear. Actually, very simple concept. Earth is a bigger charged object. It has large amount of negative charge. Therefore, actually, negative charge of earth comes towards this body and they neutralized it. They neutralized it. Therefore, then this charge is eliminated from this side. Is in next diagram, we say that the body is, whole body is negatively charged. Negatively charged. When we remove this charge, this object, positive charge, that body is negatively charged. This is a concept of induction. By the phenomena of induction, opposite charge is produced. By the phenomena of induction, opposite charge is produced because we take that's nearby this positive rod, then it's produce a negative charge on another body. Similarly, when we are going towards the positive, what is the concept? That concept is another very important. See, same diagram, positive, negative, similar numbers. Correct? And isn't this by another second diagram, we taken out a negatively charged plate nearby this. That means in this condition, a positive charge of this object comes this side and another side is negative charge. Then again, we earth this object is connecting by the earth and negative charge on that side. Correct? And in this condition, these negative charges are shifted to the earth. Same as you have their very simple concept of earthing wire at your household wiring system. Similar, we are touching by this earth, we are earthing, then the whole electrons are shifted to the earth. It means earth that's going out. Is in this condition, we shift there at the positive charge. Whole body is positively charged when we remove this negative rod. Is in this condition, again, negative rod comes towards the neutral body, that body is positively charged. When we taken out the positive, then it's negatively charged. It means by the phenomena of induction, always opposite charges produces, and this is a process of charging by induction. Is in this condition, only single body can be taken out charger. But how it is possible? Two bodies are taken out charged and opposite nature of charges. Is it possible? Then is in Next segment, we are going towards two bodies can be charged simultaneously. Come. Again, this is a phenomena of induction. Again, this is a phenomena of induction can be charged by this concept. Please see on that side. There are two bodies A and B are taken out in contact, simple as, no problem. Is in this condition, there is no another charged object can be taken nearby. That means number of positive and negative are same in both the bodies, but some of them has their more number of positive or negative, another has their less number, no problem. Then is in this condition, again we are taken A and B object nearby this object. We are taken positive or negative? Okay, positive planes. Positive. That means is in this concept, both are touched at that time, therefore this is a positively charged. Towards this, and negative charge are come, and other side positive charge, other body, that's the different body, is in this condition separated towards. Then next one, when we are shifting, they are shifted together differently. A and B object, they separated, is in this condition, therefore this object is totally negatively charged and this object is totally positively charged. Therefore, two objects can be taken out at two different charges. That means a single time we create a double amount of that charge, negative and positive, by again the phenomena of induction. Next one, next topic. Next concept. There is a law of very important concept according to board examinations, according to our competition examination. If we are going towards the NEET or the MENS, then very important concept is quantization. Then we say that's what to understand by quantization. Again, right now, quantization, Z-A-T-I-O-N, that's the quantization of charge. What do you understand by the quantization of charge? That time I am saying that's very simply, and one electron is shifted, two electron is shifted, therefore whole number of electron will be shifted from one body to another. Is in this condition we say that in the phenomena of quantization, that concept is Q is equal to plus minus NE. This is a quantization. What do you mean by this concept? NE. That means N is their positive integer, That means its value is 1, 2, 3 and so on. This is a whole number, and E is the amount of charge. That means 1.6 into 10 to the power of minus 90 coulombs. Hence, there is N is equal to 1. Then Q is equal to either positive or negative, I don't say. Positive or negative both, 1 into E. E is 1.6 into 10 to the power of minus 90. It is equal to plus or minus 1.6 into 10 to the power of minus 19 coulomb. That means when one electrons are leave from that one, that body is positively charged, 1.6 10 to the power minus 90, and those one taken out this negative charge of the electron, then its charge is 1.6 10 to the power minus 19 coulomb, and it is equal to the charge of one electron. It is equal to charge of one electron. When N is equal to 2, then Q is equal to plus or minus 2 into 1.6 10 to the power of minus 19. It is equal to 3.2 into 10 to the power of minus 19 coulomb. It is equal to twice of E. If there is a number 3, then Q is equal to plus minus 3 into 1.6 10 to the power of minus 19, then plus or minus 4.8 into 10 to the power of minus 90. It is equal to 3E, or so on. It means we have taken out the value E, twice of E, thrice of E, and so on. Hence, this is a principle of quantization. And what do you mean the quantization? Quantization is the total amount of charge or the charge on a body is always the multiple of positive integer or the number, positive number with the charge of electron is called quantization of charge. That meaning is charge cannot be divided into further parts. It means charge never be possible on body thrice of E by 2. We are not taking out because 1 electron, 2 electron, 3 electrons are leave from the body. Then it is not taken out in this way. Or 1 by 2 of E again and 1/4 of electron. It means this is for example, that's my example, this is not a book example, but this example is most important for you. Suppose this is a pen. आपका your friend will not have their pen, तो आप इस पेन को क्या करेंगे? उसको देना है. That's our friend. तो हम इसको बीच में से तोड़ेंगे, break down, then half portion इसको दे देंगे, half आप रख लेंगे, और from this side you are writing. It is possible? Never. Same as this is quantization. Same as the charge, full electrons is shifted from one body to another, or another body is taken out, full number of electrons and then number of positive integer. It means 1, 2, 3, 4 and so on. That's called quantization, and that simple concept is finishing. Then there is another very important word. What is the word? Word is fundamental charge. This is 1 marks question. What do you understand by fundamental charge or the basic charge? This one is called fundamental charge. This is called fundamental charge, or this is known as basic charge. Basic charge. What is meaning of this fundamental charge? Fundamental basic क्या मतलब है? इसका concept ये कहता है कि that's the least possible value of charge on a body. Least possible value of charge on a body, that is E. That single charge of electron is called fundamental charge. Again we define the least possible value of charge on a body is called fundamental charge or basic charge, and its value is 1.6 10 to the power of minus 19 coulomb. Okay, we discussed some problem related to quantization and what do you mean the quantization and how much amount of charge on a body we discuss on this point. Come. Next, that's next para is there. If a charge on a concept is Cu double plus, copper double plus, you find the amount of charge. What is the charge on this one? Very simple. N is 2. Correct? N is 2. E, there is no positive negative because it is positive integer. E is equal to 1.6 into 10 to the power of minus 19 coulombs. Then the charge is positive, this is plus, and Ne is the formula. N is 2, E is 1.6 into 10 to the power of minus 19 coulomb. Then the charge on Cu double plus is 3.2 into 10 to the power of minus 19 coulomb, and this is the amount of charge on Cu double plus. That's concept. Another question, that's very important question. Which amount of charge is not possible on an object? This is a question right now. Suppose there are 4 alternatives are given. First, 1.6 10 to the power of minus 19 coulomb. Second alternative is 3.2 into 10 to the power of minus 19 coulomb. Third alternative is 3.2 into 10 to the power minus 17 coulomb. And fourth is fourth one is none of these. None of these. None of these. Then what is the correct answer? I repeat the question. Question is, which one amount of charge is not possible on a body? Which one amount of charge is not possible on a body? This is question, and there are 4 alternatives. Which one is correct? So we have discussed on the answer. Answer is, first answer 1.6 10 to the power minus 19. This is equal to 1 electron. 1 electron, it is a charge possible. This is equal to twice of electron. Okay, and this is, oh, is it an answer? No, this is not an answer. इसका आंसर क्या होना चाहिए? आइए अपन डिस्कस करके इस आंसर की तरफ चलते हैं. इसको देखते हैं. This is an amount. Q is equal to NE. Q is given 3.2 into 10 to the power of minus 19 and find out करेंगे. E is 1.6 10 to the power of minus 19. Therefore, N is equal to 3.2 into 10 to the power of minus 19 divided by 1.6 into 10 to the power of, sorry, there is a 70, oh sorry, this is in minus 70 and minus 70 and minus 19. 16, 1.6, 2 jar, 3.2, minus 19 shifted, plus 19. There is N is equal to 2 into 10 to the power 2. It means 2 into 100. That means 200. N is a positive integer, yes or not? This is positive integer. That means it is an also correct. Also. Then answer is none of these. None of these, because all these three charges are possible on a body. Then you calculate it by the formula of Q is equal to NE. Then we get the result. Clear? Then next concept, and we are going towards next. Yeah, in electrostate. And then our next topic is Coulomb's inverse square law. Coulomb's inverse square law. Coulomb's inverse square law. What is Coulomb's inverse square law? First of all, we are going towards previous class because there is a very related concept are there. In gravitation, we know that universal law of gravitation. Universal law of gravitation is act between two different masses, and this one force, and there is an m1 mass and m2 mass are separated at a certain distance. Then the force of attraction are act between these two masses, but there is no nature now. In related to electrostate, Coulomb's inverse square law, then there is a nature of charge is more important. If both the charges are positive, they repel to each other. If both has their negative charge, again they repel to each other. And another time, one positive and one more negative, then they attract to each other. It means there isn't some differences are there, force of repulsion and force of attraction. Both the forces are in Coulomb's inverse square law, but is in respect of Coulomb's gravitational law, it is an only force of attraction, but Coulomb's inverse square law and electrostatic law is force of attraction or repulsion, and this is depend upon the nature of the charges. Is in this condition, again we see that this charge is Q1, this charge is Q2, and the distance between these two charges, suppose like that, R. Then we are going towards its statement first of all, and that time, this is first, this is second. There is an important conclusion is direction factor. On first, second is applied. It means F12. On second, first is applied 2-1. On second, first is applied 2-1. On first, second is applied 1-2. Same as 1-2. Same as 2-1. This is vector formation. These are the vector form F12 and F21. It means we say that both the conditions or the force of attraction or repulsion, both sides, both conditions, these forces are acting in opposite direction. How it is? Like the first case, please see. Is in this condition both the forces are acting in opposite direction? Yes. And same as force of attraction time, again they act in opposite direction. It means the inverse square law or the Coulomb's inverse square law follow the Newton's third law of motion. Every action there is an equal and opposite reaction. It means on that one applying similar force by this body, on this charge and at the same time applying the same force, but is in opposite direction. We drive it and we prove it in Coulomb's inverse square law. Verify Newton's third law of motion. Clear? And that time we drive the statement of Coulomb's inverse square law. What is Coulomb's inverse square law? The statement. That's the statement is when two charges Q1 and Q2, I repeat, when two charges Q1 and Q2 are placed at a distance of r, then the force of attraction or repulsion, is directly proportional to the product of these charges. This is statement 1. And inversely proportional to the square of the distance between them. On behalf of these two conclusions, number 1 and 2, we taken out F is directly proportional Q1 Q2 upon R square, and directly proportional sign is always moved by the constant. Then F is equal to K Q1 Q2 upon R square, and force is always measured in Newton in SI system, and this is and force. But what is K? K is very important. There is electrostatic constant, and K is there 1 upon 4 pi epsilon naught. K is 1 upon 4 pi epsilon naught, and epsilon naught is called permittivity of free space. Permittivity of space or free space. That's concept epsilon naught. What is the value of this one, and what about the unit? We write now this side again. That's value is epsilon naught is 8.85 into 10 to the power minus 12. This is the value of permittivity. And again in the next para we find out the value of K is in this part. Please write now each and everything in your copies, please. After that we remove this diagram. Okay. There is. Put about this one. Then put the value. F is equal to, the formula is K is 1 upon 4 pi epsilon naught. Q1 Q2 upon R square is in Newton. We know that. And the value of this 1 upon 4 pi epsilon naught is equal to 1 upon 4. The value of pi is 3.14 and epsilon naught is 8.85 10 to the power minus 12, and the numeric value taken out 9 into 10 to the power 9, and that's the final answer is F is equal to 9 into 10 to the power 9 Q1 Q2 upon R square, and unit is Newton. That's simple. This is Coulomb's inverse square law. Is in this condition. On behalf of this formula, we define something very important, 1 Coulomb charge. But first of all, we are going towards in CGS system also. But in CGS system, we know that there is a charge cannot be explained. That system basic name is ESU system, and the name is where is a CGS system or ESU system. F is equal to, that's K value is 1, K lies 1 is in this condition, then F is 1 Q1 Q2 upon R square, and unit Newton is change out is in form of diag. That's the unit in CGS system, and this is Coulomb's inverse square law. On the basis of this Coulomb's inverse square law, we explain another things by later on. Please write now. There is define, very important. 1 coulomb. Define this term. Define. 1 coulomb charge. What do you understand by 1 coulomb charge? We discussed that so many times. 1 identified. Otherwise आपको बुक से रखना पड़ेगा. You create them self. खुद अपने आप ड्राइव करो, खुद पैदा कर सकते हो, खुद ड्राइव करके अपने आप अपना एक न्यू डायमेंशंस डेवलप करोगे. Easiest formations, right? F is equal to 9 into 10 to the power 9 Q1 Q2 upon R square. It is measured in Newton. Then all the values put together and we define what is 1 coulomb charge. Please see on that side. If Q1 is equal to Q2 is equal to Q and we are taken as similar charges. Similar charge. Okay? That why we are using similar means force of repulsion. Okay? Repulsion. And a repulsive force. That's repulsive because both are similar charges. And R is equal to 1 meter. And this is Q and this is 1 meter put. But there is another numeric value. Then eliminate it. F is 9 into 10 to the power of 9 Newton. All these value put in this formula. Then you define what is 1 coulomb right now. 9 into 10 to the power 9 F. Again 9 into 10 to the power 9. Q1 into Q2 is Q. It means Q square upon 1 meter square. Correct? Cancel. Then Q square is equal to plus 1 and then Q is equal to plus minus 1. This is 1 coulomb charge. What is the definition of 1 coulomb charge? Please see on board again. When two equal and similar charges, there is equal. When two equal and similar charges are kept at a distance of 1 meter, and experience a force of repulsion, 9 into 10 to the power 9 Newton, then charge is called 1 coulomb charge. I repeat again, please see. When two equal and similar charges, because they are similar, when two equal and similar charges are kept at a distance of 1 meter and experience a force of repulsion 9 into 10 to the power 9 Newton, then each charge is called 1 coulomb charge. This is the definition of 1 coulomb charge and we define on behalf of this one. Another part related to that topic we are discussing next part. Okay, thank you.